Okay, I am Gerald G. Lugo from Igay 31. In my report, you will know more about Dielguide Antenna and I'll show you what it is and what it looks like. So now, let's start. Communications antenna designers continually strive to increase antenna efficiency or for low receivers maximize antenna gain or noise ratio. The ultimate goal being of course the uniform of one-half illuminated aperture with no spillover. Dial guides are dielectric guiding structures or subreflector. These guiding structures utilize the phenomenon of total internal reflection which can be effected at dielectric air interface to reduce spillover and provide more uniform illuminations. But before we go into dial guides, let's tackle a little bit in dielectrics. Since, as we said earlier, dial guides are dielectrics. So a dielectric or a dielectric material is an electrical insulator that can be polarized by an applied electric field. When a dielectric material is placed in an electric field, electric charges do not flow through the material as they do in electrical conductor but only slightly shift from their average equilibrium positions, causing dielectric polarizations. Because of dielectric polarizations, positive charge are displaced in the direction of the field and negative charge shift in the direction of the opposite to the field. For example, if the field is moving into the positive x-axis, the negative charge will shift in the negative x-axis. This creates an internal electric field that reduces the overall fields within the electric itself. If a dielectric is composed of weakly bounded molecules, those molecules not only become polarized, but also reorient so that their symmetry axes align to the field. Dielectrics are insulating materials or a very poor conductor of electric current. When dielectrics are placed in electric field, practically no current flows in them because, unlike metals, they have no loosely bound or free electrons that may drift through the material. Instead, electric polarization occurs. The positive charge within the dielectrics are displaced minutely in the direction of the electric field, and the negative charge are displaced minutely in the direction of the opposite to the electric field. This slight separation of charge or polarizations reduce the electric fields within the dielectric. The presence of the dielectric material affects other electrical phenomena. The forces between two electric charges in a dielectric medium is less than that it would be in a vacuum, while the quantity of the energy installed in an electric field per unit volume of a dielectric medium is greater. The capacitance of a capacitor filled with the dielectric is greater than it would be in a vacuum. The effects of the dielectric in an electrical phenomena are described on a large or microscopic scale by employing such concepts as dielectric's constant permittivity and dielectric polarizations. Electric polarization means that it is the slight relative shift of positive and negative electric charge in opposite direction with an insulator or dielectric induced by external field. Polarization occurs when an electric field distorts the negative cloud of electrons around the positive atomic nuclei in a direction opposite to the field. Here is the formula for the dielectric, where K stands for the dielectric constants equals to ER, which means the relative permittivity, and equals to the EM, which is the permittivity of the metal, over EO is the permittivity of a vacuum, which is a constant, and that constant is equal to 8.8 pi per 1 8782 times 10 raised to 12 farads per meter. As you can see on the image on the right, this is the equivalent value for the permittivity of the material. The dielectric constant is a measure of the amount of the electrical potential energy in the form of induced polarization that is stored in a given volume of material under the action of an electric field. It is expressed as the ratio of the dielectric permittivity of the material to the of a vacuum or dry air. Now, to be sure that you are truly listening, here are some multiple questions that I have prepared for you to answer. Multiple choice. Number 1. It is an electrical insulator that can be polarized by an applied electric field. A. Electric polarization. B. Electrical conductor. C. Dielectric. D. Dielguides. Number 2. The capacitance of a capacitor filled with a dielectric is blank as it would be in a vacuum. A. In the same. B. 0. C. Less than. D. Greater than. Number 3. It means that it is the slight relative shift of positive and negative electric charge in opposite direction with an insulator or dielectrics, induced by an external electric field. A. Electric polarization. B. Electric conductor. C. Dielectric. D. Dielguides. Number 4. What has the value of 8.85418782 times 10 raised to 12 farad per meter? A. Permittivity of vacuum. B. Relative permittivity. C. Dielectric constant. And D. Permittivity of material. Number 5. It is expressed as the ratio of the dielectric permittivity of the material to that of a vacuum or dry air. A. Permittivity of vacuum. B. Relative permittivity. C. Dielectric constants. Or D. Permittivity of material. You can pause the video so that you can answer, and as long as you want. Here are the correct answers. Now, let's focus more on the Dielguide antenna. The Dielguide antenna is another variation of the Cassegrain antenna, which is a parabolic antenna in which the feed antenna is mounted at or behind the surface of concave main parabolic reflector dish and is aimed at a smaller convex secondary reflector suspended in front of the primary reflector. The Dielguide antenna is a dielectric cone fields The Dielguide antenna is a dielectric cone that fills the space between the feed and the subreflector. The subreflector shape may be molded or turned into the end of the dielectric, then plated or covered with foil to form the reflecting surface. Since the dielectric fixes the subreflector position, no other support is required, so the blockage is minimized. The feed illumination travels inside the dielectric, and potential spillover is reflected back to the subreflector if the cone angle is less than the critical angle for total internal reflection. For a good dielectric electrolyte, a feed Fp over dP greater than 0.7 satisfies this condition, where Fp is equal to the parabolic dish focal length and dP is equal to the parabolic dish diameter. Again, to be sure that you are truly listening, here are some multiple questions that I have prepared for you to answer. Okay, number 1. What does dP stands for? A. Parabolic dish focal length. B. Parabolic dish diameter. C. Parabolic dish position. And D. Parabolic dish focal diameter. Number 2. What does Fp stands for? Parabolic dish focal length, parabolic dish diameter, parabolic dish position, or D. Parabolic dish focal diameter. Number 3. A blank fills the space between the feed and the subreflector. A. Parabolic cone. B. Focal cone. C. Dielectric cone. Or D. Dielguide cone. Number 4. For a good dielectric electrolyte, a feed F over D blank 0.7 satisfies this condition. A. The same as. B. Multiplied by. C. Less than. Or D. Greater than. Number 5. Since the dielectric blank the subreflector's position, no other support is required, so blockage is minimized. A. Fixes, B. Destroy, C. Does not care for, or D. Care for. You can pause the video so that you can answer, and as long as you want. Here are the correct answers. Each incoming ray focused by the parabola is reflected from the subreflector, then subject to refraction at the interface between dielectric and air. This image shows how the incoming rays are being reflected by the subreflector. The refracted rays no longer arrive at a point at the prime focus of the parabola, but are spread out and closer to the dish. Since the ray must all appear to radiate from prime focus of the parabola for the dish to work, the subreflector must be reshaped. All rays must also have equal electric path lengths, including slower propagation in the dielectrics. The subreflector shape and location must meet all these conditions simultaneously, making design of the subreflector even more challenging. A version of the Dielguide antenna has been made available to ham by the NW1B31. The figure .37 is a photo of a 340mm version of the 24 GHz. An antenna reflector is a device that reflects electromagnetic waves. An antenna reflectors can exist as a standalone device for redirecting radio frequency, energy, or can be integrated as a part of an antenna assembly. Again, to be sure that you are truly listening, here are some multiple questions that I have prepared for you to answer. Number 1. What does RF stands for? A. Radio forecasting, B. Real frequency, C. Radiant frequency, D. Radio frequency. Number 2. All rays must also have blank electrical path lengths, including slower propagation in the dielectrics. A. Equal, B. 0, C. Lesser, or D. Greater. Number 3. Blank is a device that reflects electromagnetic waves. A. Subreflector, B. Antenna reflector, C. Radio frequency, or D. Electric cone. Number 4. It can exist as a standalone device for redirecting radio frequency, energy, or can be integrated as part of antenna assembly. Letter A. Subreflector, B. Antenna reflector, C. Radio frequency, or D. Electric cone. Number 5. Each incoming wave focused by the parabola is reflected from the blank. A. Subreflector, B. Antenna reflector, C. Radio frequency, or D. Electric cone. You can pause the video so that you can answer, and as long as you want. Here are the correct answers. As a summary, a dielectric is an electrical insulator that can be polarized by an applied electric field. The Dielguide antenna is a dielectric cone that fills the space between the field and the subreflector. Electric polarization means that it is the slight relative shift of positive and negative electric charge in opposite direction with an insulator or dielectric induced by an external electric field, where it only occurs when an electric field distorts the negative cloud of electrons around the positive atomic nuclei in a direction opposite to the field. This is now the end of my report, and hope you have listened and learned a lot. Thank you for listening, and bye-bye.